everybody. It's been a while since we last looked at one of the example programs that come with YAB. So today I was thinking let's have a look at Calc. So drag it to the desktop. Alright. And just make it writable and executable. And there you have it, little calculator. Okay, let's do a few sums. 8 divided by 2.3 equals 45 times 2.4 equals, okay, seems to work. Perfectly conventional little calculator, nothing unusual about it, no reverse Polish nonsense, it's just a calculator. There's no memory function, there is a clear button, and it's just got division, multiplication, minus and plus. Oh, we must have a look at how he gets plus and equals on the same page here, on the same button. Okay, let's have a look at this. Okay, we start off with the shebang and then there's immediately sleep for 1/100 of a second, which sometimes can be very useful because it just gives your system a chance to just settle down, realize that it's running a YAB program, get into the mindset. To you, to your user, 1/100 of a second is not even perceptible, but to a computer that's a lifetime. So the first thing is find out where we are, and there we see a fairly typical little subroutine which is used for that purpose. I wonder if BB Jimmy wrote this. Seems to be in his style. Okay, so we open a window and we set the colors. So if you want to play around with this, just change these numbers and see what it looks like. And then we set minimum and maximum dimensions of the window to the same values, which in effect means that you cannot resize this. Alright, and then we set up the menu, and this is very interesting. He's using 2 hyphens here as a menu item. And that gives you a divider. I tend not to use those because it takes up space and my menus tend to be overloaded as it is. But that's a useful thing to remember. You can put a divider into your menu system. Then for the rest there's just a whole bunch of buttons. You can see each one has a name and a label which is printed on the button. And there's a bit of a correspondence there. It's B plus whatever printed on it. So those button names will come back in the main loop and will then be responded to. All right. So what is this? This is the initial 0. That's printed here. And we initialize a few variables. Okay. All right. So we start our main loop. Message number, we split message from the system. All right, and then we react. So in these cases here, all we need to do is draw it to the screen. And let's see. Oh, this is interesting. I don't see anywhere that this gets put into a numeric variable. Ah, here we go. Whenever that is needed, the string variable just gets converted into a numeric one. Okay, okay. Result types. Because calculate result, let's see, calculate A times B. So return, in this case, A minus B. Okay, but you haven't set that type yet, have you? Strings result. Let's see what's going up further there. This is very interesting. How on earth can you set the types? You calculate the result using types when you haven't actually defined that yet. Let's think about that. So we've got this. Curious. Something in the logic there that I'm not quite getting. Because what's happening at the bottom there? No, nothing that I can see. Okay. Right, so you've heard of me a lot. You've heard a lot of me talking to myself here. There's something in the logic here that I don't quite understand, which means I should have prepared better for this lesson. But you can see in any case that in each of these cases, right, the results get calculated, and then the type gets set, and then the result is drawn directly on the window, which gives a very clean look here. But I would probably have put a text edit up there and change the value of that. People like to work in slightly different ways. Right, and then we've got a few menu commands that need to be responded to. And what have we got here? If window count equals 0, okay. In other words, if we've closed the window, then we can now get out of the main loop. Right, what is the initial value of type string? Plus. So if you have a minus sum, why? Ah, yeah. I think I got it now. I think I got it. Right. So, you enter a number. Right, then you're basically, the first time you hit one of these buttons, you're basically saying +0, and then it changes it, right, which makes this now the result, and then you say, so this equals is in reality a kind of +0. Yeah. Okay, that's an unusual logic flow, but I think I've got it now. Yeah, I would have done it differently myself, but that's why, people program differently. And this certainly works. Okay, so should I set you homework? Well, you can change the color. That's easy enough. That's just playing around with it. Or how about adding some functions to it? Exponentiation, something like that. I don't think I'm going to do another lesson on this particular example app, but it's been interesting to see how the logic of it flows. So yeah, you can use this as the basis of a much more complicated apps. You can add little memory functions, M1, M2, M3, M4. You can Like I said, what you could do is change this, make it a little text edit so that you could click in there and directly change the calculation, right? So over here it would say 77 times 8. The whole equation could be written out until you hit the equal sign. So there's a lot of different possibilities that you could do with it. And this, oh, what's this? What's this? Error loading image. Okay. That would be why. Because it's looking for something in here. Okay, so let's see what that would be about. Okay. Team Maui. Oh, this thing must be quite old, really. Creating killer apps for BOS and Zeta. Wow, that takes me back. Okay, BB Jimmy, if you're watching this, this must predate both of us then. Okay, that's it for today. I hope you've learned something, because I have. I've seen an approach to programming here that I would not have thought of myself. And I can see how it has some advantages, even if at first it's not the easiest thing to think of, or to understand. See you next time around.